Ladies and gentlemen, logarithm and logarithmic functions. Now, a logarithm is nothing more than a logical algorithm. Logical meaning it makes sense. Algorithm meaning it's simply a state and a set of instructions that if you follow from one end to the other are going to do what you want it to do. So, for example, in this case, we have algorithms for solving algebraic equations. We simply take y equals 2x, and we have 2 times x, so we're going to reverse the process and divide by 2. X equals y over 2. In this case, you have y equals x squared, so we're going to square root both sides, because the reverse or inverse of square is square root. So square root of y equals x. Over here, I have y equals 2 raised to the x. The problem is, there is no such thing as the x root because you have no idea what kind of root it is. Here it was square, so it's square root. Here we have no idea what it is. You can't do it. So in this case, you're stuck with 2 raised to the x. That brings us down to this guy. If I have b raised to the y, so I have some base, some number base raised to the y, that equals x. If that is true, the algorithm says I can rearrange it and say the base here becomes the base here. The exponent here goes on the far side of the equal sign, and what was equal is now inside the log. So it's just a switch and swap. Now let's go the other way. If I have log base 2, we would read this log base 2 of 8. Log base 2 of 8 equals 3. So in this case, the base is 2. So if I were to undo it, it becomes the base of the exponent. Well, base 2 of what? Base 2 of the 8 comes out back. And that means it's been raised to a power. So the question becomes, how many 2's make 8? How many 2's multiplied make 8? And so how many 2's make 8? Well, that's going to be 3 of them, so it's 2 cubed. That is your basic logarithm. You need to be able to move from here to a log, and from a log back to an exponential form. This is exponential form, this is logarithmic form. Okay, the fact it has a log in it should tell you it's a logarithmic form. The base is the base on this side, and the base is the base of an exponent over here. So those stay fairly consistent. It's the other two that switch, whereas b is associated with x here, and y is by itself, b is now associated with y, and x is by itself. So this is the basic function. If I wanted to work a little harder at this, I have example number 1. All right, so if I have log base 3 of 27, the answer is 3. Okay, so I know this because if I were to switch it around, 3 raised to the third equals 27. 3 raised to the third is 27. That's very much true. If, on the other hand, I have 6 to the fourth, okay, if I have 6 to the fourth, well, I don't know what 6 to the fourth happens to be, so let's find out. Six raised to the fourth is 1296. So if I were to switch this around, I would say log base 6 of 1296 equals 4. So how many 6's go into 1296? 4. Now, let's do something else here. Let's say log with no base of 100. That's going to equal 2. If I go to my calculator and I type in log of 100, the answer is going to be 2. The reason is because anytime I have log with no base, the default base is 10. just like it is in every number system we use. It's log base 10. So we're really saying 10 to the what power equals 100. Well, that would be 10 squared. Now, if I say log of 432 equals what? Well, my problem is that 432 is not a perfect power of 10. And why 10? Because we don't see it, so the default number is 10. So 10 raised to what power equals 432? So the answer here, I simply say log of 432 equals 2.63. So 2.63. All right, that's some basic logs. We'll pick it up again later.